NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
This is a teleoperator, a system of man and machine working together. The machine serves as an extension of the man, expanding his ability to perform certain jobs. Teleoperators have been used in this country for more than 20 years. The Atomic Energy Commission has pioneered in the field, with teleoperators proving their worth at nearly every laboratory where radioactive material is handled. Teleoperators are becoming more and more sophisticated. Widely used in undersea research and in the field of medicine, their future potential is almost limitless. This is SAM, short for Self-Propelled Anthropomorphic Manipulator. SAM was built jointly by the Atomic Energy Commission and NASA at the Space Nuclear Propulsion Office in Nevada. SAM's job is to examine areas that may be contaminated by radiation. To direct SAM, the operator wears an exoskeletal control system, like the ones used by some hospitals to aid handicapped patients. Research is aimed at duplicating man's dexterity and body movements as close as possible. The closer they are, the better the machine can mimic and carry out useful tasks. The complete teleoperator system is made up of a television camera that moves with the natural movement of a man's head, a control console and TV monitor, and a remotely controlled vehicle and manipulator. Working in remote areas, SAM can bring back samples of plant life, take pictures, even make close-up studies of wildlife. To weld man successfully with other kinds of machines is the goal of teleoperator-controlled technology. Here, the General Electric walking truck. The human operator controls one pair of legs with his legs and the other set with his arms. Looking to the future, NASA may someday use teleoperators to repair or inspect nuclear-powered craft in space. Recently, astronaut Robert Overmyer commented on other possible manned spaceflight uses.
And inspect anything. You can inspect your own space shuttle, make sure it's ready to re-enter, as an example. You could inspect a satellite you have rendezvoused with. You could be inspecting a space station. Whatever such task you want to assign it, this remote robot would be the first step and make the first inspection. And the man may never have to go extravehicular in order to make the inspection. He can rely strictly on the television camera and the arms of this robot to do the work for him while he controls it inside his spacecraft.
This simulation shows how a teleoperator might catch a tumbling satellite, make the needed repairs, and finally return it to a stable orbit. At Stanford University, scientists are using computers to program teleoperators with artificial intelligence. They can be taught to recognize a situation and choose alternatives. In this simple task, the computer-controlled teleoperator stacks one block upon another. There is an error in the proper placement of the blocks, so based on visual information, an adjustment is made, nudging the cube so that one is set squarely on top of the other. Teleoperators. The research is widespread and varied, and is bringing men and machines into closer partnership.
Recently, a small astronomy satellite nicknamed SAS was launched from a platform off Kenya, South Africa. Managing the project for NASA's Goddard Space Flight Center in Maryland, Mrs. Marjorie Townsend. Here she describes the SAS mission.
The mission of the small astronomy satellite is to map the celestial sphere for X-ray sources. These are stars that radiate X-rays, and it's only since the advent of the space age that we even knew that there were stars in the sky that did send out X-rays, because X-rays don't penetrate the atmosphere. The astrophysicists hope that they will help to learn the origin of the universe from the data that they get back. The best launch site from which to launch high-energy astronomy experiments is near the equator at the San Marco launch site owned and operated by the Italian government. This particular launch site is a very large barge elevated on several legs above the surface of the ocean 3 miles east of the coast of Kenya in the Indian Ocean. SAS-1 weighs about 318 pounds and is orbiting the Earth every hour and a half, sending back large quantities of data.
We asked Mrs. Townsend how they ensure the spacecraft does what it's supposed to once in space.
A very great deal of effort and testing goes into building a successful spacecraft. For example, every transistor and integrated circuit is tested with an X-ray machine to see if there's anything inside that could cause a problem later on. Only tested components are used in the fabrication of circuit cards that eventually go into the spacecraft. The interconnecting harness is built with very great care and tested with extreme care, as is each circuit card, before they're all put together into the final spacecraft configuration. Then the total spacecraft is checked electrically for many, many hours to make sure that it's performing perfectly.
The small astronomy satellite, a little spacecraft doing a big job. Earth resources studies will be one of the major assignments for astronauts flying in SKYLAB, this country's first orbiting space station. One of the men who hopes to fly a SKYLAB mission is scientist astronaut Dr. Anthony England, a specialist in geophysics and geology. We asked him what a geologist might look for from the vantage point of space.
Well, as a geologist, of course, you're interested in the overall structures. I've looked at returned Gemini pictures, and you can see what a geologist calls megastructure. In other words, how mountain ranges fit together and how they fit with great fault systems that you can recognize in these over pictures. You don't get this relation from mosaics, from smaller pictures pieced together from aircraft overflights. The real use of Earth resources, and what I mean by Earth resources here is a very general Earth resources. I don't mean just ore wealth. I'm talking about crops and agriculture and sea, oceanography, sea state, temperatures, weather, all of these things. And the great use will be in the repetitive coverage and the ability to keep up-to-date inventory.
Comments by scientist astronaut England on SKYLAB, a 3-man experimental space station scheduled to fly in 1973. Apollo 14 astronauts returned more than 90 pounds of lunar samples from the moon. Discussing some of their preliminary findings, 2 of the scientists most closely involved with these samples, Dr. Paul Gast and Dr. Robin Brett of NASA's Manned Spacecraft Center, Houston, Texas.
I'm looking at the largest rock from the Apollo 14 return, which is also the largest rock ever brought back from the moon. The Apollo 14 mission went to Fra Mauro to sample rocks from the Imbrian event, which happened very early in the history of the moon, when an asteroid approximately 50 miles in diameter hit the ancient lunar crust. This impact threw material from as deep as 60 miles all over the front side of the lunar surface. We believe that this material thrown out by this huge impact represents some of the ancient lunar crust.
I think that one rather major result is beginning to emerge. Of course, we don't have many of the details of the characteristics of these rocks in hand yet, but the few fragments that we have and the previous information that we had from the Apollo 12 materials, the clues that we had there, particularly the clues from several of the soil samples and the small fragments that were taken out of the Apollo 12 soil samples. These pieces and bits of information, when put together, begin to point to a picture of the primitive moon, which to many of us is very surprising. This picture is that of a rather highly evolved planet.
The rocks that we see here from the Apollo 14 have all proved to be very different to the Apollo 11 and Apollo 12 rocks. They contain higher calcium and aluminum, lower iron and magnesium. Their appearance is different also. The particular rock that we're looking here now is a fragmental rock, or brexia, consisting of fragments of igneous rock caught up in a fine-grained mass of lunar particles which have been cemented together by impact processes. The description and science that's been done on this rock is very preliminary at the moment. Only later, as with this smaller rock here and all the other rocks that have been returned, chemistry will be done, the effect of the solar wind on the gases contained in the rock, the radioactive elements, detailed microscopic observations, so that we can understand how these rocks differ from the Apollo 11 and Apollo 12 rocks, and try and formulate theories as to how they might have formed.
Well, one of the areas that we're least well informed about on the Earth is the way the Earth looked when it was first formed. We don't know anything about how the Earth looked before 3.5 billion years ago, and we now know that much of what we see on the surface of the moon is the way it looked 3.5 billion years ago. In that sense, it is a Rosetta Stone. It tells us something about the early history of not only the moon itself, about other planets, the Earth, Mars, perhaps Venus, and even Mercury.
Apollo 14, preliminary science findings as reported from NASA's Manned Spacecraft Center in Houston, Texas. This is NASA test pilot Tom McMurtry preparing for another flight in a plane with a newly designed wing shape. Called the supercritical wing, this promising new concept from aeronautical research should substantially lower operating costs and increase the flying efficiency of future jet transports. Conventional jet aircraft wings become inefficient at about 530 miles per hour when shock waves build up, increasing resistance to the air. The new design alters the flow of air over the top of the wing, allowing the aircraft to fly faster, more smoothly, and at lower operating costs. The supercritical wing, an effort to improve and refine future jet transports through new aeronautical concepts.
Most people think of deserts as quite hot with sand dunes. Actually, there are sand dunes in the Antarctic, again in the Dry Valley area. But if you really want to think about the definition for a minute, not in terms of precipitation or the frequency or infrequency of water, but think in terms of an area that's harsh for life.
This is Dr. Roy Cameron, senior scientist at NASA's Jet Propulsion Laboratory in Pasadena. For several years, Dr. Cameron has been conducting scientific research in deserts around the world: the Sahara, Atacama, Valley of 10,000 Smokes, and of course, the Antarctic. Hot deserts and cold deserts, they serve as models for the study of Mars. Data acquired from air and soil samples in these desert areas are used to help design extraterrestrial life detectors for future planetary landing spacecraft. Dr. Cameron's most recent trip was to within 160 miles of the South Pole. He explained the significance of his work to the automated spacecraft scheduled to land on Mars 4 years from now.
This is quite important for the lander, the Viking lander, which is expected to land on the Martian surface in 1975. It will take a sample of soil and it will try to determine whether or not there's any evidence of past or present life in the soil sample. So before this is done, and as a prelude, we are investigating the Antarctic soil, a very harsh, cold, barren, arid desert soil, to see if we can find any life forms in these soils. And if there are any life forms, then what kind of life forms are they, and what are the conditions under which they exist there?
Of the total samples Dr. Cameron has collected and studied from desert areas around the world, all but about 10% have contained some form of microorganisms or life. Desert research, preparing the way for future landings on the planet Mars. These men are preparing to fly an Earth Resources Survey mission. Their target, the island of Jamaica. Recently, the United Nations Food and Agriculture Organization and the government of Jamaica asked NASA to record photographic and thermal images of the Jamaican island. NASA is presently using planes to check out sensing equipment that will one day fly on unmanned Earth Resources satellites and the manned orbiting SKYLAB. For the surveys of Jamaica, flights were made over the island and coastal waters at varying altitudes from 3,000 to 25,000 feet. On board, infrared cameras and sensors recorded photographic and thermal images as they passed over various land and water masses. Every object on land or sea emits visible light, heat, and other radiation which can be measured. From surveys like this, much can be learned about the condition of crops, forests, mineral deposits, and water resources. Some 15 field teams moved about the island to be in position when the aircraft flew over. This correlation from above and below gives scientists what they call ground truth. Although it has an average rainfall of 200 inches yearly, much of the mountain river water never reaches Jamaica's cities. Suspected are submarine springs that carry a portion of the water offshore into the ocean. Mr. John Williams of the Jamaica Geological Survey came to the Manned Spacecraft Center, Houston, to review data resulting from the 10 flights.
What we particularly wanted to do was to locate offshore discharge of groundwater. There's a very large submarine discharge of groundwater around the coast in the limestone areas, but for various reasons it's difficult to pick up. And we've seen from work in other parts of the world that it can be done by remote sensing. The other objective was to pick up water-bearing structures in the limestone. Some work was done on this from photography taken by the Apollo 9 mission, and that is where we got the idea from.
Earth Resources Surveys. During the months ahead, officials from Jamaica and the United Nations will be reviewing results of the 17,000 photographs and complex sensing data. This is the Bell SK-5 hovercraft as it made its way earlier this year from Fort Point Coast Guard Station in San Francisco to NASA's Ames Research Center, 40 miles south of there. The Ames Center made studies on how the weight of the 7.5-ton craft is distributed and affects its control. The data was gathered by oscillating the 40 by 24-foot hovercraft and calculating the natural frequency of the movements. The versatile amphibian that can move with equal ease over land or water is on loan from the Coast Guard to the Navy and is part of their advanced research program to develop a craft for year-round use in the Arctic. The sounds you hear are those made by a spacecraft component being tested before launch. It's a form of electronic language between machine and space engineer. To make use of every square inch of available space on board satellites, engineers have had to design extremely small, lightweight, highly reliable parts. It is here that microelectronics play an important role. This artwork is enlarged 200 times and shows the layout of some 2,000 computer memory elements. Here's what the end product looks like: a tiny, tiny chip weighing less than 1/10 of a gram. These are the 2,000 computer elements seen in the artwork enlargement. Compared to a pin, they look like this. One of the men closely involved in producing micro-miniaturized parts is Mr. John Lyons. He tells how these improved circuits have affected spacecraft flying in the last 5 years.
Up until 1965 or 1966, all of the data that was generated by spacecraft sensors and scientific experiments had to be transmitted back to the ground for processing. The problem that arose from this situation was that we literally began to fill warehouses with magnetic tape reels that housed this data. To circumvent this situation, it was decided that some type of computer or data processor would have to be flown in the spacecraft so that the data could be processed as it was accumulated and only the answers sent back to the ground. Now, in order to design and implement a computer sophisticated enough to accomplish this, a large number of parts had to be housed in a very small area or volume. Microelectronics is the mechanism that made this possible. It allowed us to get as many as 2,000 electronic components into a very small silicon integrated circuit.
Microelectronics, small-sized devices with a big job to do in the U.S. space program. At the press of a button, men in the science support room at Houston can call back a nearly endless stream of data from the moon. The information is transmitted to Earth by 3 lunar stations left in place by American astronauts on Apollos 12, 14, and 15. Like an electroencephalogram revealing detailed activities of the brain, computers spew forth data and pens make graphs of the moon's temperature changes, magnetic fields, and ground tremors. Mr. Richard Moak explains how the science support room is used during a mission.
This room is actually used during a mission to operate the experiments that are deployed on the lunar surface as a part of the Apollo Lunar Surface Experiments package and the sub-satellite which was deployed recently by Apollo 15. The function of the room is to operate the experiments, as I've said, that is to send them commands from this room and to gather data, both engineering and scientific data, that is generated by the experiments as they are operating today, in fact. Each experiment, as it is turned on and begins to transmit data, is followed very closely from this room from the standpoint of engineering health, that is, thermal characteristics, temperatures, data that is actually being generated on the lunar surface by the passive seismometer, for example. It has been deployed on Apollo 12 and is currently functioning on Apollo 14 and 15 and various other experiments. We are able to determine from this room whether the experiment is actually working and actually whether it is generating the data that had been expected, and we can tell about its engineering characteristics.
Scientists will be monitoring and sending commands from here to the Apollo experiments for years to come. Instruments like the seismometers that measure moonquakes are continuing to increase our knowledge of the Earth and the Moon.
The seismic experiment is telling us a great deal about the interior of the Moon. Now that there are 3 seismometers operating successfully on the lunar surface, it is possible to determine precisely the location of impacts from meteorites and the position of moonquakes. It's also possible to determine the depth beneath the surface from which these quakes are coming. These quakes are building up in large numbers at the time when the Moon and the Earth approach closest to each other, and so it's believed that the tidal effects between the Earth and the Moon are triggering these quakes beneath the surface of the Moon.
The Science Support Room, staying in continuous contact with our nearest planet. This is NASA test pilot Donald L. Malik as he prepares to fly the YF-12, a sleek black plane capable of flying 2,000 miles per hour, cruising at altitudes of 15 miles above the Earth. It is considered to be the fastest plane in the world. The joint NASA-Air Force research program is aimed at studying problems associated with propulsion, in-flight stopping and restarting of engines, heating, and structural dynamics. Information obtained from flights of the YF-12 will be used to further the development and operation of future civil and military aircraft and the proposed space shuttle.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.